Hello YouTubers and fellow hams. Well, I wanted to play around with another antenna experimental for me. It's probably been done, but hey, whatever. Loop antennas, wire loop antennas. Usually they're going to be like a delta or a square loop or even a circular loop, suspended above the ground. Often if they're fed with coax, you'll have a 4-to-1 balun on them because they are going to be a 250 ohm impedance at their feed point, and you're going to feed with 50 ohm coax. They have advantages. They tend to have a little selectivity, more sensitive at their resonant frequency and harmonics and less outside of it, so they're generally a little quieter. They sometimes will have gain. A square loop might have a slight gain over a dipole. And there's some general rules of thumb, one of which I believe, if I'm correct, you want to have them at least a quarter wavelength above the ground, similar to like a dipole, so they don't get affected by the ground as much. What if you put them on the ground? What if you just don't have them up in the air, just lay them right down on the ground? How does that affect them? Do they still receive well? Obviously, they wouldn't transmit well, but are they quieter? And so on. So I'm going to put a loop on the ground. I'm going to put out a 250-foot circumference loop on the ground, probably in a delta formation. So let's go put a loop out on the ground. I was originally going to wind a QRP 4-to-1 balun on smaller cores, which I discussed in my vlog video, the company that I ordered the cores from. It was an Amazon affiliate. They shipped them themselves, unprotected, and 2 of the 3 shattered. So I'm going to repurpose. I dug around in my box. I found a 4-to-1 that I wound a while back. It's higher power, bigger cores, but these are type 43 cores. So I'm going to repurpose this. I've got a BNC panel mount. I've got some hardware, wing nuts, screws and such, ground lugs. So I just need a box to put it in. So let's hop over to FreeCAD and make ourselves a box. Okay, to create a box for the balun, I am going to use FreeCAD, and rather than model an entire box up, since I just quickly need a simple box, I'm going to use my parametric utility box model. I created this a while back, and it consists of 3 bodies. It has a lid, a box, and a gasket. And this entire model is driven by a spreadsheet. I can come in here, it's completely parametric. I can put in the dimensions that I want, so I know that the width I want to be 50 millimeters. I've already measured the balun. And I want the length to be 88. And the depth of the box to be 35. Wall thickness can be 2 millimeters, and I'm going to use 4 millimeter screws. So I've put my dimensions in here, and what has happened is the entire box has been recalculated and resized. And you can see here it's longer and deeper and the right width. And along with that, the lid has been recalculated. It will fit. And the gasket has been recalculated that I can print in TPU. So everything has been redefined now to the size that I want. All I need to do is put my holes in the box. So I want to put a BNC panel mount on this end. And to do that, I am going to open up a sketch that I have created that has all of the, let's see here, sketch library, connectors, RF connectors. So I've created this little file with some sketches already in here. There's a power poles profile, but here is a BNC mount. This has already been measured and defined for the BNC panel mount connectors. So I'm going to copy this sketch, and I'm going to go back to my box model. Let me shrink that down, and I'll do a paste, Control V, and then there's my BNC sketch. I'm going to drag that up into the box body. And now I'm going to map that sketch to this face. so it will be right there ready to be pocketed. So I'm going to come down here to map mode, which is deactivated for that sketch. I'll click the little 3-dot menu. The first reference is saying selecting here, so I'll come over here and click on the face. And now you can see the sketch is right there. I need to move it up to the center, and let's see, the depth is 35, so somewhere around 15. Let's put it at 16, and that should put it, hard to see. No, it's still a little bit low. Let's put it at 17. I forgot the bottom is 2 millimeters. So that should put it right about center, right there. I'll hit OK. And now you can see our sketch is right there in the middle of the box. And I can simply take it and pocket it. Oh, wait, I got to make the body active. Tell it which one I'm working on. I'm working on the box body. Okay, I've got the sketch selected. I'll pocket it. Hit OK. Okay, there's our hole. Now the next thing I need to do is put a couple of holes here in the side for the screws with the wing nuts. So I'm going to select this internal surface here so I can see that border of this pad that the screw hole is in. I want to be able to see that edge right there. So I'm going to put my sketch on this surface. So I want to put my hole right about here. And I'm putting a 4 millimeter screw through there, so and I want it to bite into the plastic, so I'm going to make that 3.8. Okay, so there's my hole for the screws, and you can see it there in the box. But I want this to pocket through this side over here too. So what I'm going to do is I'm going to select pocket, and I'm going to make it symmetric to plane and set this to through all. And now you can see it came through this side as well. So there is my screw holes. And now my box is complete. Just that easy. This parametric utility box that I made up is become quite handy. Anytime I need a box, I can just hop in here, punch in the dimensions, and I got it. And all I've got to do is my details, like the holes. So now I'm going to just export these solids. I will just export the box first, and then I'll export the lid, and then I'll export the gasket, and then I can go and 3D print them. All right, the printer has finished, and I now have my box. So yeah, just like we designed, got the 2 holes here and the BNC mount there. Got the lid and the little TPU gasket that I printed. I like that parametric box model. And this will fit in there just dandy. All I got to do is mount the connectors, mount the screws, solder lugs, and solder it all up. There we go. Through the magic of video editing, it's done in the blink of an eye. So, the ballon is mounted in there. I've got wing nuts and washers out here to hook up the wires. BNC panel mount to hook up the coax. All I need to do now is just put the lid on with a little gasket, screw that down, and I'm ready to put out an antenna. I'm a little out of breath. I just put the loop out. I would have filmed me putting it out, but I just didn't have the energy to walk back and forth between setting up the camera, hitting record, walking back out, walking back and forth, moving the camera. No, I just went ahead and put it out. So anyway, I got the loop out. Feed point is right here. Let me switch the camera around. Okay, there's the ballon. Now the loop goes out, and way out there, I don't know if you can see it, there's a little orange stake. That's one corner. It's a delta loop. It goes all the way across. And over there, there's another stake. That's the other corner, and then it comes back to here. So that's a big delta loop on the ground. I've got it up off the ground so the kangaroo rats don't chew through it, and it goes back up there to the RV, to the corner where I've got my feeds for the RV, which also has my end-fed half-wave that drapes down to that wooden pole over there. So now it's ready to start being used, and we'll see how it behaves. While we're doing a sweep of the antenna, this is what I ended up with. It looks like its actual resonant point was at 2.16 megahertz, where it has an SWR of 1.1, which is pretty good. So that's interesting. I don't know how useful it is. It's not a transmitting antenna, but it's still interesting. In fact, if we look at the rest of the SWR, we see a little bit of a wiggle there up to around a little over 1 megahertz, and then it settles down just above 2, between 2 and 3 to 1. So as before, with the random wire, I hooked up the Zactec Whisper beacon, and I let Whisper transmit on it overnight, well, afternoon and overnight. This is the 160 meter footprint. Surprisingly, it actually got heard. This is at 250 milliwatts. On 80 meters, it actually got heard quite a bit. Of course, Whisper doesn't take much. You could probably transmit on a wet piece of string and be decoded, but we had quite a bit of reception there, even all the way out to Michigan. 40 meters, again, quite a bit. Up into Canada, out to as far as Pennsylvania, it looks like, to the east. So it got out on 40 meters, surprisingly. This is not a transmitting antenna. It's laying on the ground. 20 meters, not so good. We still got out there to Michigan, but it was pretty sparse. Not many stations heard us. And the higher up in frequency we go, the worse it gets. 15 meters, oddly, we seem to have directionality up to the northwest. So that's the first leg of the antenna when I was pointing it out. That was towards the northwest. And then 10 meters, just a few sporadic ones out to the east. Again, as far out as Michigan. And looks like we just about got to North Carolina. So that was some Whisper transmissions, but of course what I'm really interested in is reception. We are on the loop right now, and what you are hearing and seeing is the National Institute of Standards time broadcast. This is at 60 kilohertz, and it is a pulse width modulated digital signal that indicates the current time. It sounds like Morse code, but it's not Morse code. It's actually digital data. And I can hear it on the loop, as you can see, and you can see it in the waterfall here too. Now this is the loop antenna. I'm going to switch to the end-fed half-wave. Antenna B on the SDR play is the loop. Antenna A is the end-fed half-wave. Here we go. You can still tell that it's there, but it's very, very faint. So down here at the low extreme VLF range, we are definitely doing better with the loop. Let's switch back to the loop. Now you can definitely see the difference there. Another signal we can find down here at 100 kilohertz. I'm offset a little bit because we're in sideband mode. The red bar is the carrier frequency. In order to hear it, I'm offset a little bit so we can hear what's there. And it just sounds like a tone. Let's go back to the end-fed half-wave. And again, the signal dropped off. So the loop is definitely doing better down here at the VLF range. However, if we go up to AM broadcast, okay, so here we are in the AM broadcast range, and you can see there's several stations here. Let's go over to this one on 780. Okay, well there's several stations there together. I'm going to switch back to the end-fed half-wave. And it actually got clearer. We got less noise on the end-fed half-wave than we do on the loop. Now you can see the difference right there in the waterfall. See how it gets a little bit pinker up here? That's where I switched. So not really much of a difference down here in the AM broadcast band. Don't want that music to cause me a copyright issue on YouTube. Okay, so there we go. That's just audio. That's a Mexican station. I'm in Arizona, so I'm not too far from Mexico. And this is on the end-fed half wave. No, this is on the loop. Okay, we're on the loop. Watch the signal over here. So it's pretty steady around 15/9. I'm going to switch to the end-fed half wave. Signal actually came up, but so did noise. Still, the signal-to-noise ratio is not too bad, so it actually got better on the end-fed half wave. So the loop is not doing that great. Down here in the AM broadcast range, we had much better luck with the long wire, long random wire. And let me zoom out. We'll find a signal here. There's plenty of them, I'm sure. It's about 5 in the morning. So yeah, we got lots of signals up here. Let's just go ahead and pick one. And we'll go back to a regular filter for lower sideband, and we'll zoom in. And let's bring up the audio. Okay, so he's peaking around S6 to S7. This is on the end-fed half wave. Let's go to the loop. Back to the end-fed half wave. Not much of a difference in signal level and only a slight increase in the noise.
Good morning. I worked in Indiana and Kentucky on 60 meters yesterday. I need an antenna for 60 meters.
There's the loop.
That was CW also.
Let's find somebody that's talking more steady. I want a steady signal so we can see if there's a difference in the S meter. End fed half wave. Now watch the S meter. I'm going to wait till he's talking and I'll switch to the loop.
When it got to the point where I couldn't push the banks back any further, I actually got out the old D2 Caterpillar tractor and fired it up, and when I pushed out of the pole bar...
So not a lot of difference between the two antennas here on 80 meters, and not much difference in the noise level. It may be just a tiny bit quieter on the loop, but not much of a difference. And then as we go up in frequency, let's go up here to 7 megahertz and find a shortwave station, so we'll have a steady carrier. Here's a shortwave station here. Now, we're getting a little interference from this station beside it. If we look at these two... Now here is something I wanted to point out, because in the last video I had people in the comments ask about this. So we are looking at an AM broadcast station, and I'm using sideband, and somebody was like, you need to be on AM. And it's like, well, no, this is intentional. Now look, this station here at 7435, and there's this station here at 7440. So the sidebands between these two stations are mixing right here. If I switch to upper sideband, yes, I'm in sideband mode, but now I'm going to eliminate the interference from this station here. Let me go ahead and turn the audio back on, and we'll switch between the two, and you'll hear the difference. Nice and clear. Maybe not a great example. But you can, if you listen in the quiet areas, you can kind of hear some interference from the other station. Not a great example. I'll find a better example. But that's why I was in sideband, even though I was listening to an AM broadcast. If we go to AM... again, maybe not a great example. But you get the idea. By using just the upper sideband, we're going to be eliminating the interference from this nearby station if it's a bother. Anyway, let's look at the difference between the antennas here. So this is an AM station. It's sitting around between S9 and 10 over, 15 over. And we are on the end-fed half wave. Let's go to the loop. Signal levels dropped right off. I mean, we're still receiving it, and there's a little bit less noise. You can see the change there. But the signal levels really dropped off too. So the loop is not doing too good as we go higher in frequency. All right, it is midday. I wanted to do some receive testing in the middle of the day. I was at 5 megahertz here where WWV is out of Fort Collins, Colorado. Right now I am on the end-fed half wave, which is antenna A. And as you can see, we can see that it's there. But we can't really hear it. Let's go to the loop. There it is. S6 to S6.5. Let's go back to the end-fed half wave. It doesn't look like the signal itself got any stronger, but boy, look at the noise. We can tell it's there. Buried in noise. Let's go up to 10 megahertz. Okay, now we've got a nice strong signal from WWV. Solid S9, not too much noise. Let's go to the loop. Ah, yeah, it fell off. As I feared. The loop is 250 foot circumference, so it's resonant somewhere around 4 megahertz. Further we get from there, probably the less effective it's going to be. Let's try 15 megahertz. No, we can't hear WWV at all. Let's go to the end-fed half wave. And there it is. And not much difference in noise. So it seems the loop is not all that tremendous on the ground, except right around its resonant frequency. I don't think there's an advantage to putting a loop on the ground. I'm just not sure. I don't see one anyway. What about VLF, you might be asking? Let's go down. Okay, so here we are in the AM broadcast band. Oh. Can't have any music. Okay, there's a station there, buried in noise, and this is on the end-fed half wave. Let's go to the loop. And you can see the signal even got weaker. The character of the noise changed, but the signal got much weaker. Now there is some broadband noise here, which I believe is coming from the power lines. I've taken a portable receiver over and I have gotten next to the power pole. Bring this over. There we go. You see this here? Around the 200 kilohertz to 300 kilohertz range, and up here towards 400, this noise. That's coming from the power lines. And I think it has something to do with the power company using some kind of a RF technique to communicate with their remote stations and sensing devices. But you can see all this noise, and a lot of it here is up on the AM broadcast band too. This is on the loop. Now if I go to the end-fed half wave, now we're picking up a lot of noise up here, the upper part of the AM broadcast band. This noise down here is subdued. So it's not an overall quiet antenna, it's just different. If I switch back to the loop, the noise is less here in the AM broadcast band, but whatever this
coming off the power lines is being picked up very readily by the loop. So yeah, I don't really see a big advantage to putting a loop on the ground. I think that loops work best in the air.
Well, I didn't see any advantage. Even around the resonant frequency, when I was looking at WWV there on 5 megahertz, which is close to its resonant frequency, I didn't really see any much of a difference in signal strength versus the end-fed half wave. So yeah, it didn't really work all that well. Down in VLF, I was able to pick up the National Institute of Standards time signal on 60 kilohertz on the loop where I couldn't on the end-fed half wave. That could just be because it's a bigger antenna, maybe not the proximity to the ground. In fact, it probably would have worked a lot better if it was up in the air. That's just speculation. So, and noise, it wasn't really quieter. It was just different. As we saw, the noise picked up on the loop was still bad, just in a different frequency range. So I didn't really see an advantage to putting a loop on the ground. So yeah, I don't know. Interesting experiment. I don't know if we really learned much. You know, your mileage may vary. Maybe you want to try it yourself. Me personally, I didn't really see an advantage. So I guess that's it for this. We'll see you in the next video.
Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.